Hello, my name is Julián Garrido. I will be talking today about open science and green computing to support sustainability at the SKA Observatory and its regional centers. The SKA project is an international effort to build two radio interferometers that will be able to make revolutionary contributions to astrophysics, astrobiology, and fundamental physics. After many years working on the design phase of the telescopes, the SKO construction started in 2021, right after the Intergovernmental Organization was formed. As a result, the SKA Observatory is building two telescopes, one in South Africa with nearly 200 dish antennas, and one in Australia with around 150,000 dipole antennas. So, what's open science? Apart from a more elaborated definitions, open science represents an approach to research that is collaborative, that is transparent and accessible. Last year, we were very happy to finally see the UNESCO recommendation on open science, which is asking to set up instruments for the different aspects of open science. Another example is the European Communication on Global Approach to Research and Innovation. It will serve as a guide in implementing the international dimension on Horizon Europe in terms of the neighborhood development and international cooperation. It clearly states the commitment and importance of academic freedom, open science, open data, among others within the program. There is also the fourth pillar, Africa Initiative, in which the goal is to build capacities. And open science is included there to support this pillar. So in the end, we can say that open science is a way to democratize science, and it is a way also to achieve the Sustainable Development Goals, the SDGs. To give some examples, open science contributes to accelerate the knowledge transfer to society. This has been proved to be particularly important during the COVID pandemic, for example. But open science also contributes to speed up building skills and teaching, and in general, to the quality of education in many, many ways. Open science is also connected to the SDG 17, the partnerships for the goals. And for example, several agreements are in different places are being done to remove paywalls barriers and to facilitate access to data in general to knowledge. In the end, to avoid duplication and to facilitate international collaboration. Open science also contributes to reduce inequalities and improve gender equality. It contributes to a more objective evaluation of work and to reduce the probability of contributions being anonymized. I'd like to give the example of the open source community, where there is total transparency on the contributions, what and who does what. So coming back to the SKA Observatory, the data from the SKA antennas will go to the correlator, and from there to the signal data processor. The data coming from the same data processor is what we call the SKA Observatory data products, and these are not still ready for the science analysis. So this data will be sent to a network of SKA regional centers, and this is the place where the scientific community will have access to the data. It will be the place where the science will be done and where the data will be analyzed. So there will be the computing resources and also the tools. SKA is committed to open science, and we can find this in their foundational principles, the foundational principles of the SKA Observatory. We can see this in the SKA construction proposal, where it has a section, indeed. I believe that the SKA Observatory is the first observatory acknowledging or recognizing, defining the reproducibility as a metric of success. In the end, the SKA Observatory has been identified as a role model within the infrastructures community in terms of open science. For example, right now we are organizing the first SKA Open Science School. This will be happening in March 2023. And we are organizing it in collaboration with the SKA Observatory and other partners from the SKA Regional Center network. In fact, the SKA is contributing in several ways to open science through different projects. This is a selection. The INAS project was an European project where we will defining a federated network of SRCs in Europe. We were studying different aspects of open science in that project. ESCAPE and IANIAS are two different European projects that are also part of the EOSC platform. In particular, in ESCAPE, where we are and where SKA is contributing, we are producing tools and frameworks where the community have a bigger support to reach reproducibility by, for example, using tools like a Binder Hub, Jupyter Hub, or by preserving the software environment in containers. So apart from that, I would like to highlight that in the past there was we have been working on the definition of the requirements for the SRC network, and there have been several requirements that are very well connected to open science and reproducibility. So the SRC network will be compliant with the FAIR principles. We are expecting to gather provenance, also to have a workflow preservation. In the end, there is an important requirements on having reproducibility for what are called the advanced data products, which are the products produced in the regional center network. Another example on how the SKA is promoting open science and reproducibility is the second SKA data challenge. This is a challenge where the community is trained to use the SKA data, because I mean we need this training because it will be very complex and big data. So apart from the scientific case that was addressed in the challenge, it was included a reproducibility award. And the teams participating had to demonstrate their best practice in the provision of reproducible results and reusable methods. So we had this checklist that we could we could go through this, and some of the teams went through the whole list, others through a selection of these different aspects. But in the end, the goal was to have the reproducible results. Now, let's move on to the green computing part of this talk. I would like to start highlighting this paper from Nature, where in 2018 they were claiming that 1% of the global electricity demand was coming from data and computing centers, and there is this forecast that was saying that something between 8 and 20%, depending on how optimistic we were, will be coming also from data centers by 2030. So that's a lot. And obviously, one of the reasons is because the current way in which the community does things. I mean, we are so in need of our mobile phones, of being things in cloud. So there is a lot of infrastructure supporting this in way of living. And the scientific community is no different. Scientific community is also using these facilities. So in the end, what's happened is that during the last year, the curve is more or less flat because the data centers are doing a very good job of keeping it low. And one of the things that, for example, they are doing is to renew the older facilities and all hardware that has a higher power consumption. Apart from that, they are in a way precursor of using energy coming from renewable sources. So mega science infrastructures require intensive use of data centers. We know that, and this is one of the reasons why it's our responsibility to minimize their ecological impact and to explore new ways toward green computing. Astronomy is a data-driven community, so for us, this part is very important. This is one of the motivations why we are starting this new project that is entitled a sustainable approach to data centers of the SKA big data infrastructure, in particular focusing on the Spanish prototype of SKA Renal Center. Our partners are INAF, the Portuguese SRC, and the University of Cape Town, and this is a 2-year project. Our goals are to minimize the environmental footprint for the SKA regional centers by, for example, incorporating the green perspective during all the prototyping activities that are right now happening in the SKA regional center network, especially regarding data storage, analysis, and visualization. But we also aim to develop open science technologies to support end-to-end research reproducibility. During the project, we will be carrying out these main 4 activities. We want to use artificial intelligence tools to find new solutions to mitigate the environmental impact of the data centers, the SRCs. And for that, we plan to deploy a network of sensors in our facility. We want to study which are the best metrics to reduce this impact, and to optimize the energy consumption in the computing facility. As I was saying before, we want to create awareness and to bring the green perspective into the SRC prototypes, particularly in particular to things related to the data storage, and especially to optimize at the time of optimizing the data distribution, because there are many partners in the SKA project. Something that we have to avoid is to have a full replica of the science archive in every country. So we need to define very good strategies regarding data distribution. We also have to focus on distributed computing and stop moving data to the place where there is the code, and we have to move the code to the place where is the data. This is less expensive and more efficient. For that, also, we need to do a lot of benchmarking and profiling of the tools used by the community. This is helpful, for example, to match the software requirements to the hardware. So we make a better use of the hardware. We want to support the end-to-end scientific reproducibility. And for that, we want to focus on the critical areas, in particular, like the preservation of the execution environment, the science archive, and the collaborative environment for data analysis and processing. Last but not least, we want to create awareness of open science and also green values within the SKA community and also within the Spanish industry and in general within the society. And this is my last slide before the conclusions. I wanted to highlight which are the SKA sustainability goals. These are minimizing carbon emissions associated with the construction of the SKA, innovate design solutions. The power consumption in the observatory has been reduced to half since the early designs to the current moment. It's important to consider that 90% of the carbon emissions generated by the SKO will come from the electricity consumption in the telescopes. The SKO will also minimize waste generation. They want to maximize the reuse and recycling. They want to use environmentally and socially responsible materials. So these are a selection of the goals that have been defined. There are numbers. I mean, they have defined minimal percentages for each of these goals, and this is a very important thing. So they have clear goals. Regarding renewable energy, the SKA project and their partners have been working also on innovative solutions to reduce the power consumption and also to use clean energy. An example is the Biostirling for SKA project, where we were working to produce new generation solar dishes. So in the end, in the headquarters, which are in UK, they are using all the energy that they are using is coming from renewable sources. And for the telescopes, the sites where are the telescopes, in South Africa, they plan to use a combination of solar energy and batteries during the day. They plan to use grid energy and diesel power during the night. The Australian case is different because it's in so remote areas that grid is not an option at all. So they have to go fully for solar energy in combination with batteries and diesel generators for backups. The outer antennas, because these antennas will be spread through a lot of kilometers, the outer antennas will be using a combination again of solar energy and batteries. So just to conclude, open science encourages a sustainable approach to science, and it supports several SDGs. It accelerates the transfer of knowledge to society and promotes equity and inclusiveness. We strongly believe that the current science system is not sustainable unless reproducibility is improved and reinvention is avoided. The project that we are right now starting will address different aspects of sustainability in the SKA regional centers, and it aims to contribute to a sustainable network, for example, by improving the energy and computing efficiency in the regional centers, and therefore minimizing the environmental impact. So we still need to be aware that making big data science open in data centers is not yet a fully solved thing. So it's still a challenge, and the regional centers are a very good test bed for these developments, for this reason. So that's all. Thank you very much. I hope you enjoyed the talk. I hope to have a very good discussion next week.